Here's what we're doing today. The notes for today aren't section titled. The title of today's section is Distributions of Data. And I just kind of wanted to briefly let you know what we're doing. We're going to gather and analyze some data today. And what I mean by analyze is that we're going to put it on a histogram. And simply put, histogram is fancy talk for a very special type of bar graph. So we're going to talk about histograms today. I'm going to show you how to make them. And then, ultimately, what's important about making a histogram is analyzing its shape. So we're doing two things. We're going to make histograms, and then we're going to fit them to a shape of a distribution. And that's what we're talking about in today's lesson. But before we go ahead and make these histograms, I need some data. I need to know the month you were born in. And you can go ahead and copy this information down. I'm going to do it on the marker board here so that I can work with it and the smartboard at the same time. How many January babies do I have? None. Okie doke. February babies. 1, 2, 3. March babies. It's your birthday month. 1, 2, just 2. I have 2 of my babies in March. April babies. 1, 2, 3. Oh, me too. May babies. 1, 2, 3. June babies. 1, 2. July babies. No July babies? Oh, my daughter's a July baby. August babies. 1, 2, 3, 4. September babies. No September babies. A billion. Ooh. October. Just 1. November babies. 1, 2, 3, 4. 4 billion babies. No. December babies. 1, 2. Okie doke. All right, and then we need to collect some information on the number of DVDs are in your household. The number of DVDs you own. Oh, just guess. All right, Marianne, let's hear it. 80? Just give me a number. Grace. 50? What do you think, Tara? 20? Emily? 30? Mahoney? 73. He just has them organized by alphabet in his head, and they're like, you know, organized into genres after that. Alex? 40? Anna? You said 30? Zoe? How many? 30? Alrighty, Allie. Bree? 40? Evan? Like 100? That's not even the biggest number I got today. You can go big. Go big or go home, right? Let's see. No, we're just doing DVDs. I don't need, like, if you have it in beta, I'm not interested. Oh, you want me to put it back to 100? Okay. It's okay. Tyler, 73. Oh. Jake. 35. Nicole. 50. Margot. 75. I know, I did too. Alyssa. 70. And Courtney. 80. Alexis. 70. Get it? Go with 30. Chris. 50. Lauren. About 100? No. Nathan. 96. He also has them alphabetized in his head. Nick weighs 84. 90. Okay. Everybody got their numbers counted up there? We're all good? All right. So today, our topic is fancy bar graphs. They're officially called in this section histograms, however. So the first thing I have a chat with you about is what is the difference? And really, there's just sort of two differences. The first difference is that in a histogram, in your histogram, there are no spaces between the bars. No gaps between the teeth. Remember that we're analyzing ultimately the shape. Well, if you start throwing in some spaces in between your bars, you're skewing the shape of that distribution inaccurately. So you can't put spaces between the bars. Also, ultimately, some of these formulas are calculated by finding the area under a curve. If you're throwing some zeros in there, that's going to mess up the area you have under your curve. So, no spaces between your bars. Also, the bars are going to be oriented vertically. Some newspapers, magazines, vertically, looks like an R. You know, magazines, those editors, they like to make their bar graphs visually appealing. But ultimately, we care about the area under a curve. So all of our bars have to go straight up and down, not sideways. Not calculating area that way. All right, so the first thing we're going to do is we're not going to worry about phone numbers. Last digit in a phone number. We're not going to worry about that one. Because after I do the month one, you get the basic idea of how to do a histogram. Okay, so basic histogram, we're going to do birthday months first. So we have them over there on the sideboard. First thing you're going to draw is an X and a Y axis. It's going to look like this. Here's your Y axis. Here's your X axis. And then ultimately, your X axis needs a scale and a title. Your Y axis needs a scale and a title. And the bars are going to be filled in according to these. So I'm going to go ahead. I'm going to need to make this a little bit bigger. I know some of you are this way. Whenever you go to make a bar graph, you're like, X-axis isn't long enough when you put your intervals on. It happens to me all the time. What I'm going to go ahead and do is I'm going to put a scale and a title for the X-axis, a scale and a title for the Y-axis. The scale for the birthday months has already been established for me. That's kind of nice. Just goes January, February, March, April, May, so on and so forth. So January, February, March, April, May, June, July, August, September, October, November. Oh, see? That happens all the time. Oop, I just lopped off one too. So January, February, March, April, May, June, July, August, September, October, November, December. You kind of want to make your bars, it's hard to do when I'm standing so close to this. You do want to make your bars relatively the same width. You'll see for tonight's assignment I gave you some graph paper. That way your bars are uniform in their width, nice and straight. So I'm going to go ahead and write January, February, March, April looks too skinny, May, June, July, August, September, October, November, and December. Oh, November's pretty wide graph. Thanksgiving's in there. I'll fill up on turkey. These are, by the way, our birthday months. I said you do need a scale and a title. And now I need a scale and a title for the y-axis. So this might be the number of students born in a given month. Number of students born in a given month. And as I look there, it looks like, you know, we had months like September and July where none of the babies in this class were born. We have those types of months, but then, you know, we have an August and a November in there that go all the way up to 4. So I'm going to go from 0 to 4, scaling it by ones. You know, 0 is always at your origin. 1, 2, 3, 4. So I have a scale and a title for the y-axis as well. Okay. So now what I need you to do, you're going to fill in the bars. So you're going to make this histogram. For instance, in January, no babies are born, really no bar to draw. In February, we have 3 babies born. So I go up to the 3 and I mark it, and then I come down to draw the sides of the bar. March has 2 babies. April has 3 babies. May also has 3, while June has 2. July's got none, but August, woo, has 4. September has none. October just has 1. November, back up to 4 again. And December has 2. Ultimately, we're going to talk a little bit about today the shape of this distribution as well. Questions about this? I see some of you. You can shade them, color them, put hearts in them. That stuff I don't mind so much. But notice all the bars are oriented vertically and there's no spaces between any of the bars. No spaces between the teeth. All right. Now, what we have to talk about is, oh my gosh, what if they don't give you the intervals? What do? Well, you're going to have to figure those out. Keep in mind when I say interval, there's a synonym with it. Intervals are also called classes. So another word for interval is classes. And there's basically 4 steps to figuring out the frequency of an interval if it's not just given to you. In other words, you have to create what's called a frequency table. So first, step 1 is to decide on a number of classes, or decide on a number of intervals. To do so, it's very common to just take the square root of the number of pieces of data that you have. In other words, you could take the square root of n. But to be very honest with you, most of the time this information is given to you. Since we're kind of working together on the fly on our DVD problem today, I'll show you how I calculate the number of classes. So I have 1, 2, 3, 4, 5, 6, 7, 21, 22, 23, 24 pieces of data in this class today. Pretty close to 25. So today, when we go to make a frequency table for our DVDs, I'm going to take the square root of 25. That's 5. We're going to do 5 bars for this class. Okay, now you have to decide on the interval width for each of those classes. And to do so, we find something called the class width or interval width. And honestly, you just take the range, and remember that's the same thing as your max minus your min. And then you divide that by your number of classes, aka your number of bars, your number of intervals. Couple things you have to remember. If you get a decimal when you work out this formula, it doesn't matter what that decimal is, you must round up. In addition, if it divides out to work out evenly, you know, when you do your max minus your min divided by your number of bars, you get a whole number, you have to add on a class. And you're probably saying, why do I have to do this? Here's why. Remember that on a histogram, 100% of our data values must be represented. In other words, every single person who told me a number of DVDs that they own, every single one of these pieces of data up here have to be somewhere on the histogram. Well, if you don't round up, or if you don't add a class if it divides out evenly, you end up with homeless pieces of data. You'll notice it because you'll go to make your frequency table and you'll have somebody like, I don't know, maybe if Evan were at 200, you wouldn't have a place for his piece of data to go when you go to make your frequency table. So why we have these 2 very special situations, or stipulations rather, is to not have any homeless pieces of data. All of your data must be represented on your frequency table. So I hope that makes sense. Okay, step 3, you're going to construct classes by finding the lower limit and the upper limit for each class. And then lastly, you're going to make tick marks to tally up how many pieces of data fall in a certain class. And now we're going to do this with our DVD data. How many DVDs you folks own. We're going to make a frequency table and then a histogram for that. Okay, so, on your quiz on Wednesday, you'll have to make a frequency table. So these are the steps that you're going to follow. All right. So I did say we're going to use 5 classes. We're going to have 5 bars to our histogram. This number is usually given to you. Again, I calculated just quickly because I noticed we had 24 pieces of data, and I just took the square root of 25, that's 5. So we have 5 classes. The next thing I need to do is calculate the width of each of these bars, the class width, or how long our interval should be. Remember, to do this, I have to take my max data value minus my min, aka my range, and divide it by my number of classes, or my number of bars. Well, we just said my number of bars was going to be 5, so that's 5. And then our max data value was 100. So the largest number of DVDs owned in this class was 100. And then the smallest, looks like 20. Yep, 20. And then we can divide that by 5. So 100 minus 20 is 80. And then, that's actually even, isn't it? So 5 goes into 80. So we got 16 times. So it worked out even, which means we need to add on a bar. So we're going to go from having 5 bars to 6 bars. This is so that every piece of data gets a home. So we're going to have 6 bars, 6 classes. What's up? That's this guy right here. If it divides out evenly, you just add on a class after you're done. Questions about that? Now, in my period 1 class, it worked out to be like, it was like 32.1, but we had to round it to 33. So it's one of those 2 things can happen. I saw another hand. I don't know where it went, though. Lauren, what's up? You would see. So what's going to happen if I don't add on another bar, those max data values or those min data values, depending on how you look at it, there's no interval to put them in. I would be one short I would be a bar short of including all of the data values that we collected. So watch what happens, Lauren. And everybody else. So we have classes here. And we have frequency over here. Your first class needs to start at the smallest data value. Remember, there's no spaces in between. So our smallest data value is 20. The class width is 16. So to get the starting value for each class, I'm going to add 16 onto this number here. So 20 plus 16 gives me the next place where my next class should start. So 20 plus 16, you're at 36. And then 36 plus your 16 takes you to 52. Plus 16 again takes you to 68. Plus 16 again takes you to 84. And right now I'm at 1, 2, 3, 4, 5 classes. Well, if I add 16 onto that, finally I'm at 100. So Lauren, do you see what would happen if I didn't include this last class on? I wouldn't have a place to put Evan's data, and I forget, was it Nathan maybe? Oh, Laura, it was you. Sorry. I was like, I know it's in here somewhere. I wouldn't have a place to put your piece of data. I'd be a bar short. So that's did you see how I calculated the beginning number for each class? Okay, remember no spaces. So now I have to go back and figure out where the intervals stop. So no spaces, which means this interval, this first interval, is going to go from 20 to 35. And then this is going to go from 36 to 51. And then this is going to go from 52 to 67. And then from 68 to 83. 84 to 99. See, Lauren and Evan, I would have no place to put your data. And then 100, the next interval would start at 116, so this one stops at 115. Now, I always get this comment. I don't know if anybody has an objection to what they see. Does anybody object to this? Every once in a while, somebody will say, Mrs. Lucas, you're going from 100 to 115 in that last interval. I thought you said our class width was supposed to be 16, not 15. Remember that you're including 100 in this interval. So that is actually 16 units. So each of these classes is 16 units wide. What's up, Tyler?
Why wouldn't you use the 80 divided by 6? Okay, go.
80 divided by?
6 by 6. For the number of classes, we did go off one.
We add the class after you do that formula.
So you don't select 26.
It's that's vicious cycle of calculating the number of classes over and over again.
It's just so fast.
Any other questions? Okay, so now I have to go back and tally up our frequency of data values in each class. In other words, I have to figure out how many students own between 20 and 35 DVDs. So as I look over here, you know, I usually scratch them off as I go. So I'm looking for numbers between 20 and 35. So I see 1, 2, 3, 4, 5, 6, 7. So there's 7 of you folks. And then between 36 and 51. So 1, 2, 3, 4, 5. 5 of you folks. And then 52 and 67. Come on. Are there any of you? None of those. 68 and 83. 1, 2, 3, 4, 5, 6, 7. 7 of those people. And then 84 to 99. So 1, 2, 3. 3 of those. And then 100 to 115. I know we had 2 100s, right? Yep. So 2 people that own between 100 and 115 DVDs. What's up, Didich? We had 2.
But they were both.
No, because if I had somebody with 101, it's still going to work out, you know. Oh, wait, but then this would divide out evenly. It's not always just 1. I can't think of a case off the top of my head, but I see what you're saying. Any questions about how we got this? Nope. Alrighty. So, next up, you folks are going to go ahead and make the histogram for this. Get a little bit of practice. I'm going to check this last row of homework real quick. Please recall, you're going to make your X and Y axis. When you label your X axis, you're going to give me a scale and a title. When you label your Y axis, you have to give me a scale and a title. And then you have to draw me the bars in between. All right, so I'll go ahead and give you a minute to do that. Okay. So there's your histogram all done. And then, so for the last part of today's lesson, all we have left to talk about is what different shapes can these come in. To be honest with you, we don't go through all of the shapes. For instance, the shape that fits this graph isn't even one of the ones that we spend a whole lot of time studying. Honestly, there's 4 different shapes that we're going to spend time studying. And the first one is called skewed left. So on the next page, we have 4 shapes. First one, skewed left. And it's where the left side of the graph extends further out than the right side. And you'll see that after I wrote down the basic definition of what skewed left was, I drew a really rustic little histogram where the bars on the left side were smaller than the bars to the middle and right. So again, a skewed left graph is where the left side of the graph extends out a little bit further than the right. And I drew some low bars to high bars. And you'll see that I put the mean in the middle bar, and I put the mean in the bar above that. I'm sorry, the mean in the middle bar, the median in the bar above that. I need to talk about that for just a minute. Just looking at the shape of this graph, I feel like it looks like the tail end of a brontosaurus. Do you see it? Do you see the tail? Yeah? Okay, do you see the direction that the tail points to? It points to the left. So if you look at your bar graph, and it looks like it has a tail that points to the left, it's skewed left. Some students will look at their hand to remember these two. Like your hand, if you just hold it together kind of like that, looks like a bar graph, right? These are your lower bars, these are your higher bars, but look in the direction that your thumb points, to the left. So in general, if your low bars look like a tail or like your thumb pointing to the left, then it's skewed left. But let's say you look at the picture and you're like, I can't tell. Well, then you have to let the numbers tell you part of the story. And in this case, the mean is going to be less than the median. And here's how this plays out. You did a homework assignment last night that asked you to analyze the effect of outliers. Now, if you think about this particular scenario, your outliers are towards the lower end of your bar graph. And what do they do to an average? Well, an outlier, a low outlier, is going to pull down your average. For instance, your Chapter 10 test. Let's say we got somebody who had a 10%. What are they going to do to our class average? They're going to suck it down so far that they're going to pull it down below the person who got the median score. So in a graph that is skewed left, your mean is less than your median data value. The opposite of skewed left, you guessed it, skewed right. Skewed right just means that the right side or the upper half of the graph extends out further than the left. So you have your low bars on the upper end of the data set. In this case, you have upper outliers. In this case, your mean is bigger than the median. So this would sort of be the opposite case with the test scores. Let's say I had students do, okay, but then I had somebody get like 100% plus some bonus. You know, they're going to be an upper outlier. They're going to pull up on my class average. They're going to pull up on it so hard that the class average gets to be bigger than the middle person score, the median data value. So a graph is skewed right if the mean is bigger than the median. Also, back to my dinosaur with the tail. Do you see which direction the tail points this time around? The low bars point to the right. So it's skewed right. All right, and then the last two, sort of the case we didn't talk about yet. In a skewed left graph, your mean is less than your median. In a skewed right graph, your mean is greater than the median. Well, what happens if they're the same number? You can get one of two graphs. For us, there are other shapes besides this. The one case could be a symmetric graph. A symmetric graph occurs where your mean and your median are the same data value. It acts like a line of symmetry for your graph. It is this curve that we spend the most amount of time talking about in Chapter 11 because it is a bell curve. It's what we call a normal distribution. And then lastly, we have uniform. All our bars could be relatively the same frequency, same height. Your mean and your median would be roughly the same number in this as well. All it is a special type of symmetric graph, honestly. So that's that. I did want to take just a moment when you're done copying down your shapes to talk about your homework for tonight.